Hi students, welcome to my first session of solving the new syllabus question papers of grade 9. So ever since the Ganita Manjari textbook has been introduced, I've been thinking what could really help you in terms of your preparation. And I realized you really don't have access to much of the previous question papers based on your new syllabus. So I am securing question papers of different schools of grade 9, and I thought, why not solve it together with you, right? As a part of this series, this is the first question paper which I'm going to solve. This is a sample question paper released by our own high school, Dubai. I will in this video solve the 1 mark questions, and then next video solve the 2 mark, then 3 mark, then 5 mark, and then case studies. Yeah, so I'm going to split this up into so many portions. For you to make best use of this, if you have already finished revising your chapters and you just want to practice the question paper, I would suggest that you download the PDF of this question paper, which I have put up in the description. Download, attempt on your own within the prescribed time limit, and then go over the video to check the solutions. On the other hand, if you rather prefer that you solve it along with me, make sure you're pausing at the appropriate intervals, pause the video, try the question, and then listen to my explanation. Okay? Now, this particular question paper covers 3 chapters from Ganita Manjari. It's basically coordinate geometry, probability, and number systems. But let me look at what are the chapter names according to your new textbook. Yeah. So that's chapter 1, orienting yourself, the use of coordinates. Chapter 3, the world of numbers. And chapter 7, the mathematics of maybe, introduction to probability. These 3 chapters are covered in this question paper. Let's get started. So first, section A is what I'm going to solve in this video. The 1 mark questions. First question. The y-coordinate of a point is a distance of that point from which axis? Yeah. What is the y-coordinate of a point? What are coordinates basically? When you talk about the x or y coordinate of a point, it tells you what is the horizontal and vertical distance of that point from the origin. What is the origin? The origin is the meeting point of 2 axes, one which is horizontal. Horizontal is like a sleeping line, and that's the x-axis. And this is the vertical line, a standing line, which is like the y-axis. The meeting point of the x and y axis together gives you the origin. Now, what do we mean by this x coordinate and y coordinate? To move from the origin to any other point over here in this coordinate plane, you need to move a certain distance horizontally and a certain distance vertically, right? If I have, let's say, the point 2, 3, the first point indicates the horizontal movement. If it is positive, move to the right, negative, move to the left. So positive 2 means I move to the right by 2 units and I reach this point. And then you move vertically up by 3. So vertically up by 3 means here you go. Vertically up by 3 over here. Right? This is the point 2, 3. Now look at what this question is asking you. The y coordinate of a point is the distance of that point from which axis? Is it the x-axis, y-axis, origin, or none of these? The y coordinate over here was 3. Where do you get this 3? 3 was the distance from the x-axis because 3 tells you how much up you're moving over here from the x-axis, right? So this value 3 over here becomes the perpendicular distance from the x-axis. Hence, the answer over here for the y-coordinate would be x-axis and not y-axis. Answer is option A, x-axis. The opposite would be true for the x-coordinate. The x-coordinate is the perpendicular distance from the y-axis. So you can see over here, we moved 2 horizontally here, right? This horizontal movement of 2 We are moving away from the y-axis. So when we move right or left, we are moving away from the y-axis. X coordinate is the perpendicular distance from the y-axis. Y coordinate is the perpendicular distance from the x-axis. That's what you need to remember. Whenever you're writing your answers for 1 mark questions, make sure you write the option letter followed by the actual description. There is no mark for this working actually. Yeah, the marks are provided only for your final answer when it is a 1 mark MCQ question. Okay, second question. The ordinate of all points on the x-axis is. Okay, let's look at points on the x-axis. We know that we have the origin here in the center. Yeah, if this is the x-axis, if I have points on the x-axis, that means I'm only moving right from the origin or left from the origin. There is no up or down movement. If I'm moving only right or left, only the x coordinate is changing, right? This y coordinate remains unchanged. The y coordinate 0 remains fixed as it is. There is no change. Only thing is that the x coordinate keeps changing over here. So if I move to the right, maybe the x coordinate is becoming, let's say 2 over here. But the y coordinate remains as 0. So I have this point 2 comma 0. Maybe if I move 3 units to the left movement means minus. So minus 3. I would reach the point minus 3, but no up and down movement, which means y coordinate remains as 0. So ordinate of all points on the x-axis would be what? It would be option A, which is 0, right? The answer here was this. Okay. By the way, I hope all of you knew that ordinate means y coordinate. So whenever you have x and y coordinates over here, abscissa is a fancy name for the x coordinate and ordinate is a fancy name for the y coordinate. If you get confused between this, remember it like this. We know that x comes before y, right? X, y. In the alphabet, x comes before y and a comes before o. So remember, x coordinate is abscissa, y coordinate is ordinate. That's it. The answer over here is option A, 0. What if I asked you the abscissa of all points on the x-axis? If I asked you what could be the abscissa of all points on the x-axis, what will be the answer? In that case, it will be any number because abscissa could be anything. When you move right or left, the abscissa could be any number which you want. Okay. Third question. Which one of the following can be the probability of an event? For that, first you need to understand what is the range of values of probability of any event. When you look at probability of any event, we usually represent this like this, probability of an event A. Now imagine someone asks you, what's the probability that you're going to pass maths exam? Yeah? You may say 50-50. So that's like a 50% chance. 50% is same as half. So you can say there's a 50% probability, half chance. Maybe you'll say, oh, I'm going to definitely fail. So that means there is a 0% chance of passing, right? So it's an impossible event. I'm not going to pass this exam. 0%. That's the least. You are not going to say there is a negative 50% chance of passing. Minimum will be 0%. 0%, which is 0. What about the maximum value? Some of you might exaggerate and say, oh, 200% I'm going to pass. But that 200% actually does not make sense when you're talking about chance of occurrence of an event. Probabilities can be maximum only 100%. You can say 100%. Definitely I'm going to pass. So 100% you get. 100% is the same as 1. So minimum probability of any event is 0. And maximum probability of any event is 1. How do you read the symbol? 0 less than or equal to, then probability of an event, then less than or equal to 1. Okay. Now let's look at each of these options one by one. Option A, 6 by 5. 6 by 5 would be greater than 1. It's an improper fraction. Improper fractions are always greater than 1, so this cannot be the answer. This is a negative value. I told you probabilities cannot be negative, so remove that. Next one is 15%. 15% is 15 by 100. It's a proper fraction. Proper fractions are always between 0 and 1. Or you could have just thought of it as 15% is between 0% and 100%. So that's okay. This can be the probability. 2.5 definitely not. It's greater than 1. So this cannot be the answer. Your answer for third question is C, 15%. Let's look at the fourth question. If P of A denotes the probability of an event A, then, oh, this is just the previous thing. What have we discussed? We already discussed this formula. So if P of A denotes the probability of an event, we already saw that it should be option C. Probability of an event is between 0 and 1. Same explanation as the previous question. Fifth one. The decimal representation of rational numbers is, if you're looking at the decimal representation of rational numbers, what is a rational number first of all? Let's understand what is a rational number. A rational number is any number which can be written in the form of P by Q, where both of these are integers. Of course, denominator cannot be 0 because division by 0 is not permitted. So P by Q, both should be integers. If you can write a number in that form, that's a rational number. Now, if you look at the decimal representation, the decimal representation of a rational number would either be a terminating decimal. What do you mean by terminating decimal? Something like 0.5 or 0.731 or 0.22. There's an end to it. It doesn't keep continuing. So any terminating decimal would be a rational number. Or a rational number could be non-terminating, but there's a condition if it's non-terminating for it to be a rational number. Non-terminating but repeating. The rational number could be non-terminating, but it should repeat. Okay? Now, if you look at an irrational number is not a rational number. It means it cannot be written in P by Q form. So how would the decimal representation look like? What's left? We already covered terminating decimals. We saw non-terminating but repeating. For example, 0.3333 dot dot dot, which means 3 is repeating. So any pattern of numbers which repeats, that is non-terminating but repeating. Irrational numbers, the decimal representation will not terminate, right? And it will not repeat also. So non-terminating and non-repeating. Non-terminating and non-repeating decimal representation is what you're going to get in irrational number. As an example, you can give 1.3725417623 dot dot dot. So there's no repetition, there's no visible pattern. It never repeats even after maybe 100 digits. There's no repetitive pattern which appears, right? That is an irrational number. Very popular examples of irrational numbers are pi. You have square root of prime number. Any square root of a prime number would be rational. For example, root 2, root 13, all these would be rational. Let's answer the question now. So I have already explained this. What is the decimal representation of a rational number? Which option is the best? It will be option B. A rational number would be either terminating or repeating. One of the two it has to be. Yeah. So write either terminating or repeating. Next question, sixth one. The points -5, 2 and 2, -5 lies in which quadrant? Okay, let's understand about where points could lie when you talk about the XY plane. So this is the x-axis, that's the y-axis. Points can either lie on the axis itself. If a point is on the x-axis, then the point would look like x comma 0. We saw this earlier. If the point lies on the y-axis, then the point would be 0 comma y. Since there is no right or left movement on the y-axis, the x-coordinate would remain 0. Y-coordinate would depend on how much up or down we moved. So these are two possibilities. The point lies on x-axis or the point lies on y-axis. Of course, origin lies on both the x and y-axis. Other possibilities, it lies in any of these four regions. What are these four regions called? The four regions are called quadrants. These four regions over here are called quadrants. Now, this would be the first quadrant, that's the second quadrant, you have the third quadrant next, and then the fourth quadrant. How do we distinguish these quadrants? First quadrant starts where the x-axis is positive and the y-axis is positive as well. Let me write that neater. Yeah. So we know this is the positive x-axis. That's positive for x. And y-axis is also positive over here. So this region is bound by the positive x and the positive y-axis. We have both coordinates positive. What about the second quadrant? The x-axis is negative because you're moving to the left of the origin. And y-axis is positive. So between negative and positive, x coordinate negative, y coordinate positive. What happens in the third quadrant? Both are negative. We have the negative x-axis and the negative y-axis. So both are negative. In the fourth quadrant, x is positive, y is negative. Positive, negative. Now, let's look at this point. There are two ways to answer these questions. One is you actually draw the xy plane completely and then try marking these points. Identify which quadrant they are. You can, of course, have memorized those sign schemes also and then answered. Yet another way is when you have the point minus 5, 2. Imagine you're starting with the origin. Yeah, there's a point which is the origin. From the origin, minus 5 means I move to the left and then plus 2 means I move up. So which quadrant are we reaching? We are reaching the second quadrant here. In second quadrant, remember, second quadrant is bound by the negative x-axis and the positive y-axis. What about the next point? 2 comma minus 5. From the origin, we are moving to the right because first is the right or left movement. Plus 2 means right. Minus 5 means we move 5 down. So we are moving 5 down and we reach here. This movement indicates that we are to the right side but below the x-axis as compared to the origin. So we are in the fourth quadrant, right? We are bound over here by a positive x coordinate and by a negative y coordinate. This portion would be the fourth quadrant. So what's the answer here? Which answer do we select for this question? For this one, they both are not in the same quadrant, of course. They are in second and third, no. Second and fourth, respectively, yes. Don't answer fourth and second by mistake. You should always stick to the order. We have minus 5, 2 mentioned first. Minus 5, 2 corresponds to second quadrant. 2 minus 5 mentioned second. 2 minus 5 corresponds to fourth quadrant. Yeah. So sixth answer over here, minus 5, 2, second quadrant. And 2 minus 5 in the fourth quadrants. Okay, next question. Seventh one. One number is chosen at random from the numbers 1 to 10. So total options over here are what? Total outcomes which is possible. When you're choosing any one number from 1 to 10, the total possible outcomes are 10. Either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? One of those outcomes. And what are the favorable outcomes? Okay, what's the probability that the number is not divisible by 3? Which are the numbers from 1 to 10 which are divisible by 3? Are divisible by 3 would be 3, then you have 6, 9. How many numbers are not divisible by 3? Those which satisfy the condition which is mentioned in the question are called favorable outcomes. Any values which satisfies the condition which is mentioned in the question are called favorable outcomes. We are interested in the count. That means the number of favorable outcomes. What is the number of favorable outcomes here? It's 3. 1, 2, 3. Right? Oops, I made a mistake. Did you realize what's the mistake I made? The number of favorable outcomes here is a number that's not divisible by 3, not divisible by 3. I have put 3 as the number of favorable outcomes. That's wrong because the question is not asking how many numbers are divisible by 3. It's asking how many numbers are not divisible by 3. Yeah, let me remove that. So what is it? How many numbers are not divisible by 3? 10 numbers are there in total. 3 numbers divisible by 3. So how many are not divisible by 3? It's 10 minus 3, which is 7. What's the formula for probability? Probability, that means the chance of something happening, is the number of favorable outcomes to the event divided by total possible outcomes. So my answer here is option C, 7 out of 10. Let's look at 8th question. The point whose ordinate is minus 3. Okay, ordinate is minus 3 means the first coordinate must be minus 3. Are we right? No. Ordinate stands for y coordinate. Ordinate is the y coordinate. So the second coordinate is minus 3. Ordinate is the second coordinate. Remember, the first one is the abscissa, second one is the ordinate. So ordinate is minus 3, lies on the y-axis. The moment you see the point lies on the y-axis, what is the abscissa? What is the x-coordinate? X-coordinate will be 0. So this would be 0. This would be the answer, 0, minus 3. And that's option B. 9th question. Classify the numbers as rational or irrational. Okay, see, when you see perfect square, right? Any square root of a perfect square. So if you have root of a perfect square number, what are perfect squares? Perfect squares are squares of natural numbers like 1, 4, 9, 16, 25. These are all perfect squares. Root of a perfect square will always be a rational number. All other numbers, that means if you're taking square root of any number which is not a perfect square, that will 100% be irrational. Just remember that. Root of a perfect square, rational. If the number is not a perfect square, when you take the square root, it will be irrational. So all you have to test over here is whether this 925 is a perfect square or not. Yeah, you have to test over here whether 18 is a perfect square or not. Is 925 a perfect square? Well, we know that 30 square would be 900. Yeah. What will be 31 square? As per what you learned in your 8th grade, 31 square would be 30 square plus the 31st odd number. So it will be 900 plus some number which is 100% greater than 25. So I know 31 square is definitely greater than 925. What does that mean? 925 is not a perfect square. So you could say that root 925 is irrational. Another way to answer if this method is confusing for you is prime factorize 925. Yeah. When you prime factorize 925, what do you get? If I divide by 5, then I divide by 5 again. Yeah, this is what we get. So we are getting root 925 is same as root of 25 into 37. Now this 25, 5 into 5 is a perfect square. So that will become 5 root 37. 100% this is irrational. What about the next one? Root 18 is easier. Root 18, we know that 18 is not a perfect square. If you're writing the steps like this, you would have said root 18 is root 9 into root 2, which is 3 root 2. So what type of number is this? This is also irrational. What's the answer for this question? I am going to say both irrational. Which one is giving me that option? D. We will say D, both irrationals. Okay. Let's look at the next question. 10th one. The distance of the point 7 comma minus 6 from the x-axis. Okay, this is similar to the very first question that we did. What did we discuss about the distance of any point from the x-axis? We are talking about the perpendicular distance here. So when we talk about the distance from the x-axis, we are referring to how much up the point is or how much down the point is. We are referring to the magnitude of how far away the point is. So when we have a point 7 comma minus 6, 100% this would be below x-axis. It's not going to be above x-axis. It's going to be below. That's why the y-coordinate is negative. So if I was drawing the complete xy plane, 7 comma minus 6 would be a point somewhere over here in the fourth quadrant. And we know that this distance over here, that means the downward movement from the x-axis would correspond to 6 units. This is how you calculate the distance. Now tell me, is the answer option B minus 6 or is the answer option D plus 6? Well, answer cannot be minus 6. If you are going to mark directly this minus 6 as the distance from the x-axis, that's going to be wrong. Why? Because distance can never be a negative value. Distance always has to be a positive value. So, yes, the coordinate is minus 6 over here when you look at the y-coordinate. But how far away is it from the x-axis? It is 6 units away from the x-axis. That is the distance. Do not put minus 6. You're going to select option D, 6 units as the answer over here. Yeah. Let's look at 11th question. Which of the following has a non-terminating decimal? Which of the following has a non-terminating decimal? How do you classify between terminating and non-terminating decimals? What's the way to go about it? Let's say you have a rational number, p by q. Okay, we know that if it has a non-terminating decimal, there are two possibilities. Either it's an irrational number for sure, or it's a rational number, but the non-terminating kind. So you can see from all the options, all options are given as rational numbers. Basically, you need to see where it is non-terminating repeating. So when you have any rational number p by q, which can be written in the form of a by b, where a and b are co-prime integers, there is a way you can find out what type of decimal representation it has. Now, I hope you remember what co-prime integers are. Co-prime integers are basically integers which don't have any common factor except 1. The highest common factor would be 1. For example, if I have a number like 12 by 15, this is a rational number, but it's not in the simplified form because we have not cancelled the common factor yet. What's the common factor for 12 and 15? 3. So you can reduce this to 4 by 5. 4 and 5 both are co-prime integers. They don't have any common factor except 1. Once you reduce a rational number to the simplest form, then what are you supposed to do? Check the denominator. The denominator over here is 5. Now, the rule is if the denominator has only 2 or only 5 or only 2 and 5 as its prime factors, then the number is terminating. If there is even one more extra prime factor, that means outside of 2 and 5, you have any other prime factor in the factorization of the denominator, then it is not a terminating decimal. For it to be a terminating decimal, only 2, 5, or only 2 and 5 must be its factors. So this is the condition for a terminating decimal. Let's look at these options one by one. 3 by 8. 3 by 8 can be written as 3 by 2 cube. This has only 2, so this is terminating. It is not a non-terminating one. 7 by 20. I can't reduce this further. So let's just directly factorize. 20 is 4 into 5. I can write this as 2 square into 5. Do you see again over here? Only 2 and 5 are coming as prime factors. There is no other prime factor which comes. So this is also going to have a terminating decimal expansion. If you look at the next one, 8 by 30. 8 and 30 have common factors too. You can reduce and cancel out the common factor from both the numerator and denominator. We can write this as 4 by 15. Now let's prime factorize the denominator. When you factorize the denominator, you get 3 into 5. Okay, this is a troublemaker here, 3. The moment you have a prime factor outside of 2 or 5, you are going to say that this is non-terminating. Right? This is going to have a non-terminating decimal expansion. So that's obviously our answer here. Just for explanation's sake, I'll just show you the next one. 13 divided by 250. This is 25 into 10, 5 square into 10, which I can write as 5 cube into 2. So again, only 2 or 5 as the prime factors for the denominator. This one is terminating. Our answer over here is clearly option C, which is 8 by 30. This is the one which is a non-terminating decimal expansion. 12th question. In a bag, there are 100 apples, of which 70 are rotten. A bulb is taken out of the bag at random. The probability of the selected apples being good is, okay, I'm having 100 apples, 70 are rotten. So, if a bulb, where did bulb come from in this question? This is only talking about apples, right? There's a mistake in the question. This is an apple. An apple is taken out of the bag at random. Probability of the selected apples being good. Okay. If 70 are rotten, yeah, exactly 70 are rotten. How many would be good? 100 minus 70, which is the remaining 30 would be good, right? So what's the probability of selected apples being good? It's just 30 good apples. That's the total number of favorable outcomes divided by total number of outcomes, which is 100. So you'll get 30 by 100 and that's 0.3. You have option C, 0.3 as the answer. If you look at the next two questions, these are assertion reason type of questions. There is a specific way that you answer assertion reason questions. How do you answer assertion reason questions? Whenever you answer an assertion reason question, individually, without connecting the two statements, check whether they are true or false. So check separately whether the assertion is true. Check separately whether the reason is true. Only if both statements are true individually, then you need to check whether the reason is the right reason for the assertion or not. Otherwise, that doesn't matter. You don't have to check it up separately. Yeah? Let's look at the 13th question. If I look at the assertion, there are infinitely many rational numbers lying between any two irrational numbers. Of course, that's true because between any two numbers, you can write infinitely many numbers. It is possible. Any two irrational numbers if I take, for example, if I take 1.1732543, and if I take another number 1.2732543, I can write so many both rational and irrational numbers between these two. I could have written the rational number 1.18. I could have written 1.2. I could have written 1.19. I can write 1.1934. All these are rational numbers which are there between these two numbers because they're all terminating. So this is definitely true. What does the reason say? There is only one rational number lying between any two irrational numbers. That's just the total opposite of what we showed in the assertion, right? When you say there's only one rational number. No. Mostly you will make a mistake if you're going to think of rational numbers only as integers over here. then definitely, depending on the example you take in mind, you may make a mistake. Don't do that. Remember, rational numbers could be any non-terminating decimal. It could terminate after 5 decimal places, 6 decimal places, doesn't matter. So there are infinite possibilities of you taking numbers between any two irrational numbers. Reason is also, oh, not also, reason is false, as we saw. Reason was the opposite of the assertion. So reason is false. What option do we choose here then? We'll say assertion is true, but reason is false. So option C, assertion is true, but reason is false. Look at the 14th question. That's the last 1 mark question in this paper. The 14th question says assertion as -11 -13 lies in fourth quadrant. Both negative. Is it possible? So if I have negative x-axis, negative y-axis, this quadrant, which is bound by the negative and negative x-axis and y-axis, is it the fourth quadrant? No. We call this the first one, this the second, this is the third, and this is the fourth quadrant. Over here, the assertion is definitely false because fourth quadrant, both coordinates won't be negative. In the fourth quadrant, the x coordinate will be positive and y coordinate will be negative. What does the reason say? Abscissa and ordinate are negative in third quadrant. Yeah, that's true. But actually, it did not matter. The moment you got assertion is false, there is only one option which says assertion is false. That is option D. D says that assertion is false, but reason is true. Okay, I think we solved this 14 questions in 35 minutes, which is quite good. Okay, because I did it with explanation as well. So that's good. Normally, what I would advise is when you get, let's say, 14 questions, as in this case, you can spend around 2 minutes per 1 mark question maximum. Many of these questions were quite easy. It wasn't that complicated, not time consuming in terms of calculation. So we were able to do it in less time. But if you get such a paper in the exam, 14 questions, which are 1 mark, I would have advised maximum take 28 minutes for this, not more than that. That's the maximum time you would spend on section A. So always calculate it as 2 minutes per 1 mark question maximum. If you're going beyond that, if you're taking for 20 questions, let's say more than 40 minutes, that means you're losing a lot of time on the 1 mark questions. It will lead to problems for the remaining section. Please time yourself this way. So that's it for this particular video. You want to continue solving the paper with me, refer to my next video in this playlist where I'm going to solve the remaining sections as well. And if you have any doubts on what I discussed, please post them in the comments. If you have any other extra doubts outside of this video, that's also welcome. And students, if you are from other schools, please do share your question papers with me so that I can solve them over here in my channel. Thank you so much. Bye-bye.